Okay, guys, what does linear regression mean? Linear regression, simple linear regression, is a way to try to evaluate the relationship between two continuous variables. We did something like that before, or in the project you are supposed to do it, okay? We have an x variable and we have a y variable, and we are trying to find out the relationship between x and y, okay? This is continuous variable and this is continuous variable. Like the simple linear means there is a kind of line relationship, okay? Linear means kind of a line, okay? Either like that or like this or like that, with different slopes, with different intersection points, okay? So these are the things that we will be discussing today. This x might be the weight of the people. This might be the height of the people. This might be the ÖSYM score or YKS score of the person. And this is the GPA of the person, okay? This might be the sleeping hour, okay? Average sleeping hour for each person. We will have many data coming from people, and we might have GPA as the y. So what are we trying to do? What is the relationship between the sleep amount and the GPA? What's the relationship between weight and height of people? Is it like as we increase the weight, does the height increase, or vice versa, or there is no there is no relationship, or the relationship is very weak, okay? There might be different situations like that. So we will say one of them is going to be the predictor, one variable. As I said, there is x and y. X will be the independent variable. If you remember from signals and systems course, we were saying that this is time, and time is an independent variable. And for example, voltage is the dependent variable, and the voltage V of t, for example, V of t is like V is my voltage and time is my independent variable, voltage is my dependent variable. Why? Because the voltage is changing with respect to t. Here, we are saying that independent variable or explanatory variable or predictor variable is x, and the other one is called response variable or outcome variable or dependent variable y, okay? So that's why it's like simple x and y. We will have two variables like that. What is the name of x? Predictor, explanatory, or independent. Y, response variable, outcome variable, or dependent variable, okay? This will be changing, and this will be changing with respect to x, okay? That's the main idea. So I gave you some examples. For example, heights and weights, okay? One of them is x, one of them is y. You can put the weights of the people and heights of the people and try to understand the relationship between them. For example, outdoor temperature and evaporation rate, how does it change with respect to each other? But there has to be a kind of randomness, okay? It cannot be like this. For example, I have a conversion, okay? For example, I have a conversion from Celsius to Fahrenheit. From Celsius to Fahrenheit. How do you go from Celsius to Fahrenheit? You know, Fahrenheit, like 32 Fahrenheit is 0 degrees Celsius. And then if you put C is equal to 0, Fahrenheit will be equal to 32, okay? This is also 1.8. So if you know this is like 10 degrees Celsius, then it will be 1.8 times 10 plus 32, which is 18 plus 32 is 50 Fahrenheit. Okay, now the relationship is deterministic. There is no randomness here, okay? So that's why if I want to draw this Fahrenheit versus Celsius, okay, Celsius and Fahrenheit, if I put C is equal to 0, Fahrenheit will be equal to 32, and there will be a slope of 1.8, right? There is this relationship between Celsius and Fahrenheit. If it is 10, Celsius is 10, this is going to be 50. If it is 20, this is going to be 76, I guess, right? So I can understand, or I can find the Fahrenheit temperature using the Celsius temperature. But the relationship between them is deterministic. Deterministic means there is no randomness, okay? There is no chaotic relationship or statistical relationship between two variables. It is like, if I know X, if I know C, I can immediately find out F. But if I have a statistical relationship, then there is no exact relationship, okay? There is a kind of trend between X and Y. For example, here you can see the relationship between different states in the US, okay? And this is 27, this is 48, and this is the latitude, okay? Enlem, paralel, okay? Enlemler. And this is the mortality. That means people who die in 10 million, for example, 100 people die in 10 million population, okay? So this is a kind of mortality, dying relationship, skin cancer versus state latitude. If it goes down, okay, this is close to the equator, okay? This is close, this is more south, this is more north. As we go down, down, down, what happens with the mortality rates of people who live in that state, okay? There are 50-something states in the US. You see 50 states in the US. And then you can see, for example, one of the states has like this, latitude, parallel, enlem, and the amount of people who die in 10 million population, it's around 200, okay? You put a dot here. For another state, you get this data, this is the latitude, and this is the mortality rate. You put another dot here. So this is called scatter plot, okay? This is called scatter plot. In MATLAB, if you say scatter, then if you have X and Y's, you can come up with a scatter plot, okay? So is there such a deterministic relationship between latitude and mortality? No, there is no such Y equals X plus something, okay? But there is a kind of statistical relationship. There is a kind of randomness in my data. So that's what we are trying to do is, I want to come up with such a line, okay? This is going to be my linear, simple linear regression line, okay? This will be my regression line. What is the basic idea? What is the basic idea? I'm trying to find out the relationship. I want to come up with a kind of equation. If you remember from high school, we were writing y equals mx plus n, or y equals ax plus b, right? Similarly, using this scatter plots, using x and y values, which are statistical values, which are random, they are not deterministic, it's not like a simple conversion kind of thing, then I will be able to come up with these y equals mx plus n, y equals ax plus b kind of relationship, which is called statistical relationship. Okay, guys? So I have latitude information here, I have mortality rates here, and then using this data, I want to draw this line. The concept that we will be covering today is how I can come up with this line. How I can come up with y equals mx plus n. What is the slope of this line? What is the intercept of this line? You know, when x is equal to 0, you see, here is my, let's say, here is my line. This is x, this is y. What is this value? When x is equal to 0, this is x is equal to 0 and y equals to 4, for example. Okay, this is 4. When y is equal to 0, this is, let's say, 3, right? So this is called intercept. We will talk about this, and we will talk about the slope. Okay, what's the slope? Minus 4/3, tangent of this, right? 4/3, but because it is reverse, it should be minus 4/3. We will talk about these. So what is the basic idea here? I am trying to find out the trend using the scatter plot of the data. Okay, what kind of a data do I have? I'm going to have a latitude data and mortality rates. Okay, for example, one of them is 28, mortality is around 195. There's another state which is like 32 and mortality rate is 180. Okay, I have such 50 values, and using the scatter plot, okay, L, M, then you can come up with this plot like that. Okay, so this is the first step. First, you come up with the scatter plot, then you try to find out the relationship between data points, and you try to find out a line which will best fit to these data. Okay, I will talk about the details in the coming parts. Okay, I hope this is clear, guys. Now I want you to understand. I want you to write in chat what is linear regression. What am I trying to do in this concept of linear regression? Please write to chat. The basic idea. Here's the thing that I was trying to explain to you. I have a line like this. There is a slope, which is m. Okay, this is the slope, and b is going to be the y-intercept. Y-intercept means where does my line cut the y-axis? Okay, y-intercept means where does the line cut the y-axis? Okay, so that's called y-intercept. So in all these efforts, we are trying to find out this line in linear regression. Okay, what is the slope? It is like change in y versus change in x, right? Change in y versus change in x. That means it's a kind of tangent. We are trying to find out how much change in x will create a change in y. Okay, how much change in x will yield change in y. So that's one of the things that we are using for the slope. So here in this part, or in this live session, we will be trying to find out how I can come up with this y equals mx plus a or mx plus n kind of thing using the data that I have in my hand. Okay, it's not like x and y is not deterministically related with each other. There's a kind of randomness in my data. Okay, so here is another way of representing my line. This is my dependent variable. This is my y-intercept. You know, I am trying to find out the relationship between weight and height in all AGÜ students, like more than 3,000 people, but I don't have enough information about them. And finally, I am trying to find out a relationship between weight and height of AGÜ students using only 50 students information. Okay, but now this is the population slope, this is the population intercept, this is the random error that we have in our plots. Because why random error? I have this line, but I have data here. I have data here. It's not exactly the line, right? Here's my data, and here is my line. So there is an error here. There's an error here. So in all these things, in all these lines, we will have some kind of a random error, okay? And we will try to minimize this error in this linear regression model, okay? So let's continue. Again, this is my dependent variable. This is my independent variable. For example, this is height, this is weight, or vice versa. This is sleep information. This is the GPA. This is college, high school grades, and college grades. Is there a relationship between these two? And these are the intercept, which means cutting y point, and B1 is going to be the slope, okay? You see, these are population slope, population intercepts, okay? We should be careful on that. So let's continue. This is my population. I have many data. And then I don't know the relationship. What was the relationship? Beta 0 plus beta 1 xi plus the error, right? That was my relationship. I don't know what beta 0 is. I don't know what beta 1 is, okay? And using these, I am collecting some subset of the whole population. It's going to be my random sample. And using this random sample, I will try to find out beta 0 hat plus beta 1 hat plus errors, okay? So what is beta 0 hat? What is beta 1 hat? These are my estimates, okay? Actual intercept and actual slope was something that I don't know. What am I trying to do? Collecting a sample, and from that sample, coming up with some estimates of the slope and the intercept, and trying to understand what is the relationship between X and Y in the population. You remember, why do we use estimation concept? Why do we use estimation word? Estimation means kestirim, tahmin, okay? So that's why I'm trying to estimate or predict the relationship between two continuous variables, continuous random variables, using a random sample. We have a sample and we are trying to find out as something that we did before, right? We were trying to find out the interval where the mean, the population mean is, or we were trying to find out let's say whether this mean is different from the population mean, okay? So we were trying to estimate different things. So if you think about that, let us try to understand this beta 0, beta 1 kind of thing, okay? Here is, you see, the title is population. Now we are trying to find out population thing, okay? In the population, 1, 2, 3, 4, 5, and 6 values have been observed. 6 values. Only our population is 6. Number of items that are in my population is 6. And I have this red line, which is my model, which shows the relationship between X and Y using this data. The random error here is this, okay? My point and this point, my point and this point, my point and this point, okay? So error is the actual value minus the predicted value. You know, error is actual value minus the predicted value. It can be minus or plus. If it is, for example, the actual value is big, the predicted value is small for this X value. You see, this is my X. Let's say this is X3, and this is my predicted Y3. The actual Y3 is here. What is my error? Error of error of third sample, it is going to be actual one minus the predicted one, right? This is the actual, and this is the predicted value. So we will base our linear regression model generation process by minimizing this random error. I will try to draw such a line that this random error to the total random error will be minimum. You understand, arkadaşlar? I am trying to minimize the error. I will draw such a line. If I would draw such a line, my error would be different, right? If I draw such a line, my error will be different. So I will try to find out such a line equation that my random error, total error, will be minimum. Okay, this is our observed values, real values from my population, and this is my predicted model, or model that I will be using to predict. Model means I am trying to come up with a relationship between two variables. Okay, it is let me check. Ahmet Serdar is asking a question. Hocam, we have different points and generating the exact equation is not possible. Exactly. That's why we are trying to using the least squares method to minimize the error. Exactly. This is what we are going to be trying to do. Okay. So we don't have an exact relationship between x and y. The relationship is statistical. I cannot say x and y is equal to 2x plus 1. I cannot say exactly like that, but using the data that I have, I will come up with a relationship between x and y with some error, and I will try to find out such a relationship that the error will be minimum. Okay, you covered these, I think, in linear algebra course. It's called linear least squares method. Okay. So here the concept is like we have the population like that. Now I am collecting some data. How many data do I have? 1, 2, 3, and 4. I couldn't observe these 2 points this time. You see, the previous line, the previous prediction was like this. The actual relationship, let's say, actual prediction model would be like this from my population. This would be the population. Now I have a sample of 4 points. Using these 4 points, again, using the minimum, I'm trying to minimize the error. Okay, this time my error is again different, right? Random error is different. Before it was like this, the error was like that. Now it is like this. So the errors, even the error predictions are different. Okay. Here, my actual relationship is y plus. Okay. So this is my prediction. Okay, this is my prediction. This is the population relationship, this red one, and population relationship is maybe different from what I'm trying to find out. Okay, sample might be different from the population, but I will do all my observations, all my modeling based on my samples. Okay, using my samples, I'm gonna perform least squares method, and I will try to find out the relationship between x and y using the data that I have. Okay. For example, if I have such data points, how can I find the best fit data, best fit line? Something like this, right? I can do it with my eyes. For example, if my data were something like this, then I would draw something like this. If my data is a little bit more scattered, then I would do this. Okay? using my data points, I am trying to find out such a line that this error, the total error, okay, from all these points will be minimum. Okay, that's why it's called least squares. I will talk about what squares or what least squares method mean. Okay. As I said, we first start everything with a scatter plot. Okay. Now I want you to open your Excel and come up with some numbers which might be similar to this one. Okay. For example, this is 11 versus 21, for example. This is 20 versus 39. This is 25 versus 7. This is 35 versus, let's say, 15, and 40 versus 55, and 50 versus 58. Okay, I want you to come up with an Excel file right now. Put X and Y like this. What did we say? The first value is 11. Corresponding value is 21. The second value is 20. The corresponding value is 38 or 39, and so on. I want you to come up with this. And then I want you to perform a scatter plot in Excel. Okay? Can you do that? Arkadaşlar, yapıyor muyuz? Bilgisayarlarımızı açtık. Bilgisayarın başındayız. Ve Excel'imizi açtık. Excel'de de X ve Y parametrelerimizi gördüğümüz grafikteki gibi oluşturalım. Sonra da acaba Excel'de bir fonksiyonla ya da bir çizim plotting function var. Onunla scatter edebiliyor musunuz? Bir görelim. Scatter plot çizebiliyor musunuz? Evet, ben sizi göremediğim için yaptığınızı farz ediyorum. En azından böyle bir pratikle başlayalım. Şimdi bunu kullanacağız bir sonraki adımlarda. Tamam mı? So, let me go back. And here's some prediction model, right? How did I do that? By eyeballing, it's called eyeballing. Just by looking at the data, I can come up with such a line which would fit this data with minimum error. What was error? The point here minus this one. Point here minus this one. Point here minus this one. How can I find this one? Okay, guys, let me change the color. Okay, how can I find this one? It is, for example, this is y equals 0.9 x plus or minus, let's say 5. Okay, how do I find this point? My prediction, I will put 20 here and find out what is y. 20 times 0.9, 18 minus 5, it is 13. So it is going to be something like this. What's the actual value? This is 39. So what is the error? The distance between these two will be my error. Okay, you understand, arkadaşlar? How do I find the predicted value? Predicted y, and x is my value. This is going to be my prediction. Okay. So, but what is the trick here? I have some data. For example, I don't have any data from this x. I don't have any data from this x. I don't have any data from this x or this x. By coming up with a model that will fit best with these available data, I can now easily find out the relationship between x for any x value to predict any y value, right? For example, what is the value for when x is equal to 45? We're going to come up here using this equation, you're going to find out the y value. Okay, that's how we will use this concept also. In your project, you're gonna you will have, let's say, 100 points, x and y. Okay, you have 100 points, and you're gonna use 80 of them. For example, weight and height information from 100 people, and you will use the first 80, for example, to come up with the model. Okay, like this, and then you're going to use this model to predict the weights of the other 20 people. Now you have 20 test people here. You're going to come up with height information, height predictions from this model that you generated, and then you're going to find out the error between the predicted height and the actual height. You know what the height of that person is. You predicted the height of that person using your model, and you try to find out the error between these two. Arkadaşlar, burası anlaşıldı mı acaba projeyle alakalı? You have many data. You're going to use some of them to train your model, to come up with a relationship, linear regression model. And then you're going to test your model using this prediction equation, and then find out the error between your predictions and the actual height values, for example. Okay?
Hocam, can I
Yes.
ask something? Hocam, all these calculations and tests should be done on Excel or can be done on any other program?
Anything you want, Excel, Python,
Okay, hocam.
Java, MATLAB is fine for me. Okay?
Okay, hocam, thanks.
There is no problem for my. They are tools, but I want to understand that you grasp the idea. Okay. So what is the linear regression? We are trying to find out a model that will fit the data, that will fit my x and y pairs. Okay. X and y pairs can be plotted using my scatter plot. I'm going to come up with a model which is y equals the slope times x plus intercept plus the error. Okay, the error will be there, but it won't be in my model. So I will try to find out the best fit. Okay, so actual y values and predicted y values, the difference between them should be minimal. That's what I'm trying to do. Okay, so let's go with that. Can you feel this thing, arkadaşlar? Can you by reading this, can you come up with the equation for the best fit equation, guys? How do you find out the square error, total square error? How do you come up with total square error? I'm gonna sum. This is my actual data. This is my predicted data. And I'm gonna take the difference between them and then take the square plus I'm gonna have my error, predicted error, and then square it like this. Okay, I have n data points, and then here is my squaring error. Is there a mistake in this equation, arkadaşlar? Is there a mistake in this equation? Yes, there is. There should be an equal sign here. Okay. Do you see that this is my error? We did that before, right? We said that here is my point, and here is my prediction, and point. there will be an error between them. This is my x1, this is my y1 actual data, and this is x1, and this is y1 hat. This is something that I found from my prediction equation. And then I'm going to find out the error between these two. And this error will be y1 minus y predicted value squared. Okay, the difference between the actual value and the prediction. I'm going to take the square. Why do I take the square? Because if I add the errors, for example, the error here is, for example, negative, okay? And here there is another one, and this is my prediction, this is my actual value, this is positive, this is negative. They will cancel each other out, right? We don't want the errors to cancel each other out. That's why we say let's square the errors, and then that's why it's called least squares, okay? Least squares. Actually, it's called least square error. Least squares error, okay? Error, this is my error. I'm gonna square it, and then it's gonna be my total error, right? Total squared error. So that's why I'm going to try to minimize the sum of the squared differences or errors. Sum of the squared error. Okay, least squares method is trying to minimize sum of the squared differences. Okay. Did everyone understand this concept, arkadaşlar? Hocam, that's the error, but that's not least error. We will derivate from this. Yes, exactly. So this is something that we will start our discussions. Okay, we will have the actual values. We will predict different. We have the actual values. Okay, this is my actual value, and I will try to find out such a line that this errors, the sum of squared errors will be minimum. That's what we will be trying to do. Okay, the sum of squared errors will be minimized. That's what we will be doing. Arkadaşlar, anlaşıldı mı acaba bu bahsettiğim şey? 5 dakika içinde bir araya gireceğiz. Evet, peki. So what is the error here? For example, this is error 1, this is error 2, this is error 3, error 4, but these are predicted errors, right? Predicted errors. So this will be my actual point, actual data, actual data. So this is x1, this is x2, this is x3, this is x4, right? So I have the actual population data, beta 0 plus beta 1 plus errors, right? The actual error. But my prediction is going to be beta 0 hat plus beta 1 hat. Okay, why do I put hat? What's the difference between hat? What is the difference between this one and this one, arkadaşlar? What's the difference between beta 0 and beta 0 hat? What is the difference between these two? One of them is the actual population. The other one is the sample, right? You got the main idea. So the error will be, okay, I'm gonna add these, and I'm gonna say I'm gonna add all these errors, epsilon error 1 plus error 2 plus error 3 plus error 4, but I'm gonna take the square of each of them. Why do I take the square? Because I don't want to lose the information of error just by canceling them each other. So I will try to minimize the errors, the absolute errors, let's say, okay? Absolute errors, like the actual value is 100, you're finding 90 or 100, 110. They are the same. The amount is the same, right? One of them is 100. You find 90 or 110. It is like the error is, let's say, 10 here. This is minus 10. I don't want them to cancel each other out. So I'm going to take the square, 100. Take the square, 100. So the error square will be the same. What is my goal? I am trying to find out such a line that the predictions will be close to the actual value. Okay, this is what these squares do. Okay, this is my prediction equation. Beta 0 hat plus beta 1 hat times xi. This is my independent variable. This is my prediction or predictor or outcome or dependent variable. Okay, so beta 1 is the covariance of x and y divided by variance of x. Okay, how do I find the variance, guys? How do I find the variance? Can you complete this denominator here? What is the variance of x? How do you find the variance of random variable x? I have data x1, x2, and xn, and I'm going to find out the sample mean. Okay, exactly, Süleyman, thank you. I'm going to subtract x1 from the sample mean, x1 minus x hat. I'm going to take the square plus x2 minus x hat square, and so on, right? So we will try to find out the variance is going to be something related to xi minus x bar. What is x bar? Sample mean. What is xi? Data. Okay? Data, ith data, first person, the data coming from first person. For example, height of or weight of the first person, weight of the second person, and so on. What is the covariance? Same thing, arkadaşlar. We are gonna multiply this. Actually, this is what? Xi minus x bar times xi minus x bar. That's why it's like this square comes into play. How about this one? This will be, covariance will be my data minus my sample. Now this is zero mean here for x, again zero mean for y. Okay, zero mean for x and zero mean for y, and then I'm going to multiply them and add them up for all i's. I'm going to add them up for all i's. Okay, so my beta 1 hat will be equal to covariance divided by the variance. Okay, so this is something that can be derived. I won't go into the derivations. I just want you to understand covariance divided by y. For example, if I give you 1, 2, 3, and 2, 3, and let's say 5. Okay, this is x and this is y. Can you find the covariance? Sorry, let's do this 6. Can you find the covariance of x and y?
No, true.
You can.
How we don't have x bar and y bar.
You're gonna find it out, right? You're gonna compute this. What is the mean What is the mean of this or average of this? This is x1, this is x2, this is x3. What is x bar? X bar is the average of these three, which is 2. Right? Y is 2. Daha düzgün bir sayı çıksın diye uğraştım ama 2, 3, 5, 4 olmasını istiyorum. Neyse şöyle yapalım o zaman. 2, 3, 6 olunca 11 oldu. Şunu da 7 yapalım olması. So what's the mean? 2, 3, 7. The mean is 4, right? So this is Y bar. Burası anlaşıldı mı arkadaşlar? Yani elimizdeki datanın ortalaması X bar. Elimizdeki datanın ortalaması Y bar. So how do I find the covariance using this data? What is the covariance? We are going to say 1 minus 2 minus 1. 2 minus 2, 0. 3 minus 1, 1. Okay, we found this. Now I'm going to find this one. 2 minus 4 minus 2. 3 minus 4 minus 1. 7 minus 4, 3. Now I'm going to multiply these, which is 2, which is 0, which is 3. What is the total value? 5. This is my covariance. Do you understand arkadaşlar? Bir daha yapayım mı? Bir daha açıklayayım mı burayı? Yoksa herkes anladı mı? Ses yoksa anlaşıldı demektir. What is the variance? We found these as my difference between xi and x bar. So now I'm gonna take the square of each. Square of minus 1 is 1. Square of 0 is 0. Square of 1 is 1. So I'm gonna add these up and my variance is 2. So I found my variance being 2. I found my covariance being 5. So my beta 1 will be 5 over 2. If you remember, what was my data? 1, 2, 3. For 1, it is 2. For 2, it is 3. And for 3, it is 7. Right? These are my data points. And then 5 over 3. So there will be a slope like this. And then it will be like that. Okay, let me change the color again to green, to this. Okay, we will do some practices like that. Okay, and then y-intercept beta 0 will be equal to, beta 0 will be equal to, can you find the equation for this, guys? Y hat plus beta 1 x bar. Okay, y hat, sorry, y bar, that means the intercept, sorry, the mean of this, okay, plus beta 1, that's what we found here, 5 over 3 times x bar. We will use these in our equations, arkadaşlar, okay? What was my goal? I was trying to find out the prediction equation, and I was trying to find out beta 0 and beta 1. This will be my prediction equation. If I put any x, I will be able to find out the predicted value for y. And then beta 0 and beta 1 will be something that I need to find out. How do I find beta 0 and beta 1? Using these values, covariance divided by variance, and sample y-intercept is going to be like this, okay? So let's have a break here. Let's have a 10-minute break. After that, I will give you I will want you to work on the data that you had in Excel or in MATLAB or anything like that, that you found the scatter plots. Using the scatter plot, I don't want you to use exactly what Excel gives you. I want you to use this covariance and variance calculation stuff, okay? And then you're gonna come up with beta 1 and beta 0. Okay, let me give you these are some problems here. Okay, so I want you to, there's a problem in my PowerPoint, so I will let you have the correct version in the second half. Süleyman asks, Hocam, can we accept the actual values y and x as the data taken from forms that we created? Exactly. That's what I want you to use, okay? The actual values are the ones that you have in your data set, okay? For example, you collected data. Here is the money that people are earning, okay? Monthly salary. This is credit card, okay? For example, monthly salary is you can normalize it, or you can do some tricks with that. For example, the guy says, I earn 20,000. You can say 20. How much credit card they are using? 15. The guy says, I am earning 25,000 Turkish liras. I am using credit cards for 30,000. Okay, and so on. These are your X1 and Y1s, okay? X2, Y2. And finally, you're gonna draw this X1, X2, X3, many points like that, and Y1, Y2, and so on. So you're gonna have this data like this, and then using this covariance and variance, or beta 1 and beta 0, you're gonna come up with the least squares line prediction, okay? You're going to come up with a prediction equation. Then, for example, you used 80 of your data, and you're going to come up with 81 up to 100, the last 20, for testing your prediction equation. How well your prediction equation is good for modeling your overall data. Okay, that's what we need to do in the project also. So now, after the break, as I said, we had an Excel file with the data we came up before, and I want you to come up with beta 1 and beta 0 using Excel equations or MATLAB equations, okay, finding the covariance and variance and intercept, and come up with the prediction equation. Tell me after the break, what is the prediction equation for that data that we had in the previous case, okay? Let me go back to this data. We talked about this before. I will keep this here. I want you to look at the data here. There are 1, 2, 3, 4, 5, 6 points. Come up with X and Y's. Come up with a scatter plot. Then using Y hat is equal to beta 0 plus beta 1 hat X prediction values. I want you to find out this beta 0 and beta 1 and come up with the equation, and then find the errors. Okay, guys, I want you to do this in MATLAB or Excel. Find the errors, total errors for your prediction equation. Okay, so see you in 10 minutes. It is now 9:50. We will see each other at 10 o'clock. Okay, inshallah. Okay, have a nice break. We will be using this prediction equation using the slope, sample slope, and sample y-intercept. And then so we will be using the data that we have, we will be finding out our prediction equation. Okay, let's continue. This is the derivation of how we found the y-intercepts. Okay, I will share these slides with you. You can check them. It's all about minimizing the error. How do you minimize the error? You take the derivative with respect to beta 0 and equate it to 0. That's how we find the minimum, right? This is a calculus 1 concept optimization. We take the function's derivative with respect to x or beta 0 or beta 1 and find out the relationship that will make this error minimum with respect to beta 0. Okay, so that's why we find this. And then if we go to the second part, how do I find beta 1? Which beta 1 will make this error minimum? This is how we find it out. Okay, and we find covariance divided by variance. Okay, what is covariance? How does my data change with respect to each other? Okay, we had one example, 1, 2, 3, 2, 3, and 7, right? This was x, this was y. X hat was 2, y hat or y bar is 4, and we found xi minus x bar values and yi minus y bar values. And then in order to find the covariance, we multiply these two and add them up for all i's, right? We have 3 points here from 1 to 3. This is how I find covariance of x and y. How do I find variance of x and variance of x? Again, like this. Okay, from 1 to 3, I'm going to subtract each and every data from my mean and take the square. Take the subtract from this and that, take the square. Subtract the data from the mean and take the square and add them up, and it will give you the variance. Okay, there are divided by n minus 1s, but now they will be canceling each other out. That's why we can only we can easily find out our covariance and variances using these formulations. Okay, in Excel you can write some functions to find those variances and covariances easily. Okay, so finally, what do we have? I have a prediction of y for each I value. I have a beta 0, which is my intercept, sample intercept, plus my slope, beta 1, times my xi. Okay, this is the real value, or this is something like independent, and this is the dependent variable. Okay, so what does slope mean here? For increase in y in x 1 unit, our slope will tell me how much will my data change in y. Okay, for example, let me give you this. Okay, here it says if beta 1 is 2. For example, let's have this kind of a relationship. Y is equal to 2x plus 1. When x is 0, it is 1. And when x is 1, it is 3. When x is 2, it is 5, right? So this is how I can plot my function if I know the prediction line like this. What does it say? If there's a change, like 1 unit change from 1 to 2, how much change do I have in y? From 3 to 5, right? The change in y is going to be 2. The change in x is going to be 1. The slope tells me that for each 1 unit increase in x will lead to 2 unit increase in y. Okay, that's why the slope has this meaning. How much my data will change, how much my output or dependent variable will change when I increase 1 unit in x. Okay, if this is 2, from 2 to 3, it will again be 2. From 3 to 4, it will again be 2. So it will be increasing in 1 unit increase in x will create 2 units increase in y. Okay, so that's what beta 1 is used for. Okay, and then if you go to the intercept, what does intercept mean? Average value of y when x is equal to 0. Again, this is what we say about intercept, right? If x is 0, what is y? It is y-intercept, right? This is beta 0 hat. When x is, if you think about that, beta 1 hat x plus beta 0, if x is 0, y is equal to beta 0, right? So what does beta 0 equals to 4? Then the average y is expected to be 4 when x is equal to 0. Okay, so if x is equal to 0, I will be able to find out. This is again like high school stuff, but related to statistics. Okay, that's why I said it's a very easy concept that you will really understand fast. Okay, in many papers, in many research papers, you're going to see this r squared value. Okay, for example, people will present their scatter plots like this, and then they will say r squared is equal to this, or they can present it as like this. What does r squared mean? R squared is a value which shows how well my prediction is with respect to the data. Okay, you can see how I determine the r squared coefficient. Okay, so this is covariance square divided by variance of x times variance of y. Okay, which is something that you found earlier. You know how to calculate variance and covariances. Variance of y, we didn't do that, but let's do it. Variance of y is equal to yi minus y bar squared. Okay, from I1 to n. Again, take the difference between your data and the mean of your sample, and then add them up, take the square and add them up. That's what is found. Okay, so the r squared value will be always between 0 and 1, and if r squared is close to 1, that means my prediction is close to the value, the data. Okay, let me give you one example like that. Okay, for example, this is the regression line that I have. This is the regression line that I have. This is the first regression line. This is the second regression line. And I have these data. You can see that r squared is high here. Why? Because it's a good fit. The error is quite small. Okay? Here, the error, you see error here, error. And there is a kind of scattering or error is high when you think about this regression line. Okay, now I want you to tell me from chat, I have this data and I have such a line and I have another data this is 1, this is 2, this is x, this is y. This is x, this is y. This is my prediction line or regression line. This is my regression line for the same data set. Like this is, let's say this is R1 squared, this is R2 squared. Which one is higher? Which one is close to 1, arkadaşlar? Which one is close to 1? Second is close to 1, right? Second one is high or higher. Second one is higher than the first one because my regression line is much closer to the data points and my errors are smaller. So when you see an R-squared value on your Excel files, or you can do that in MATLAB also, then you're gonna interpret that R-squared. Oh, my fit is really good. Okay, but it all depends on your data. If your data is so much scattered, obtaining an R-square very close to 1 is impossible. Okay, for example, you have such a data. Okay, so maybe like this. So you want to have such a regression line, but your R-squared will be somewhat away from 1. Okay, so it all depends on your data, depends on your regression line, but finally you will say, what do you report as a researcher? You say, this is my prediction line or regression line. This is my prediction equation. And my R-squared is this. Okay, R-squared, some kind of a coefficient that represents your error in general. Okay, but in the exam or in your project, you should also be able to tell me what the sum squared error. What is the error for this regression line and this regression line? Okay, how do you find that? This is my data, this is my prediction. Take the difference, take the square. This is my prediction, this is my prediction, this is my data. Actual minus predicted, square, add them up, okay? So the error here, error squared, or some error squared here will be higher than this one, right? That's why R squared is higher here. So you should be able to give me the error, total error, okay? Enes is asking, Hocam, if we split our data into a training and test set, if my training set R squared value bigger than test set R2 value, what does it mean? Enes, or all my friends, we are not trying to find out an R squared value for the test set, okay? We usually do it for the training set, okay? Because what is the training set? What is the meaning of training set? We are trying to come up with a regression line. For example, I have data, like 80 data points, like this, from this data points, and I'm trying to find out a model. And I'm going to say, this is the best fit to my sample, but it also can be representative of the population. Now, I have this equation, okay, beta 0 hat plus beta 1 hat x. Okay, this is my equation. Now I'm going to do everything on this. I'm not going to do an R squared calculation for the test set. Okay, this is whole thing from the training set. It is like you are training the model, you are training a person for further tests, right? For further tests. Now you have this model. You're going to say, okay, there's a test data from another person. The weight of that person is, let's say, 65 kilograms. Now I'm going to put the 65 kilograms here. I know beta 1 and beta 0. And I'm going to find out the height being, let's say, 172 centimeters. This is the weight, this is the height, but this height is predicted height. And normally, you wouldn't know the height of the person, but for performance analysis purposes, you say, I know the weight and height. This is like 170, but I find it 172. So the error in my prediction, in my test data, will be 2 centimeters. You can find the error in your training data but it's something different, okay? For the test, you don't find R squared. You only find R squared for training data. And then you use the model using the training data to predict the height of the people that you know the weights of, okay? Is that clear, arkadaşlar? Do you understand the difference between training set and test set? Do you understand this difference, arkadaşlar? Test set, training set. Şunun gibi bir örnek veriyorum ben genelde. Bir çocuk oturuyor karşımıza. Ben ona tükenmez kalem ve kurşun kalemin farkını öğretmeye çalışıyorum. Önüne farklı renklerde, boyutlarda, tiplerde kurşun kalemi koyuyorum. Diyorum ki bak kurşun kalem bu. Bakıyor, öğreniyor. Sonra tükenmez kalemleri koyuyorum. Tükenmez kalemleri tanıyor, öğreniyor. Train etmiş oluyorum bu kişiyi. Sonra hiç görmediği yeni bir tane kalem koyuyorum. Diyorum ki bu kurşun mu tükenmez mi? O da diyor ki bu kurşun kalem. Tamam diyorum. Bakıyorum. Gerçekten kurşun kalem mi? Evet. O zaman bunun hanesine bir doğru işaretliyorum. Bir başka bir kalem daha koyuyorum. Bu tükenmez mi? Kurşun mu diyorum. Ama birbirine çok benzeyen iki kalem. Tükenmez karıştırılabilir. Tükenmez diyor. Halbuki kurşun. Tamam diyorum. Burada yanlış yaptı. O zaman performans doğru yanlış. Yani kurşun kaleme kurşun kalem deme. İşte tükenmez kaleme tükenmez kalem deme. Kurşuna tükenmez, tükenmeze kurşun deme hatalarımız da diğerleri olmuş oluyor. Burada da eğitim verisi üzerinden bir model oluşturuyorum. Sonra test verisiyle de bu modelimin performansını, bu modelimin ne kadar iyi bir model olduğunu, ne kadar datamıza uygun bir model olduğunu, genel genel popülasyonu represent edebilir bir model olduğunu test etmeye çalışıyorum. Hiç görmediği bir veriyi de sunduğum için adı test datası olmuş oluyor. Bunun aynısını makine öğrenmesinde, derin öğrenmede de yapıyoruz. Is that clear, guys? Is everything clear? En iyi sonuç veren eğitim verisi ile test verisi arasındaki oran nasıl olmalı? Normalde there are different ways to choose training sets. Okay, you can randomly choose. This is not the topic of this class, but normally, what do? We separate our data into 5 or let's say 10 different groups. Okay, let's say I have group 1, group 2, group 3, and group 4. And there are 30 people here, 30 people here, 30 people here, and 30 people here. I say, I'm going to use the first 3 for the training, 90 people for the training, and test on the last 30 people. I say this is called fold 1. Birinci kere. Then I say, I'm going to use 1, 2, and 4, and leave 3 out. Again, I'm going to have, you see, fold 1 is 1, 2, 3 is my training data, and test data is 4. Fold 2 is going to be, training data is going to be 1, 2, and 4. The test data will be 3. And fold 3 is going to be 1, 3, and 4. And test data is going to be 2. Fold 4 is going to be 2, 3, 4. And test data is going to be 1. So I am repeating myself many times. We call this cross-validation. We repeat this process many times and try to find out the best representation of the best prediction model, which will give the minimum error between your data and the test data and the prediction model. So that's how we usually deal with this, with our data. But in your project, you are just going to choose randomly 80. Let's say you have 80 data points, okay, 100. You're going to randomly choose 80 of them, okay, not the first 80. Randomly choose 80 of them for training. Rand function, you can use rand function for that. and then 20 for test. Okay, but you know, if the training is somewhat very different from test, your test performance might be low. That's why we call it like generalizability. Okay, genelleştirilebilirlik. Yani we want to have such a training data that it will serve for a generalizable model. Okay, but for this purpose, for now, for your project, I don't want you to push too much. Just choose 80 random training data and leave 20 out, and then find your model prediction equation using this 80 training samples, and then test on 20 samples and comment on the error that you have. If you want to do it once more, choose another 80 random samples, come up with another prediction equation, test at another randomly chosen 20 sample, and then comment on the errors and your R squared and so on. Okay, so with equal, hocam, in project it is said that with equal proportions. Equal proportions, did I say equal proportions? You can do that also, but usually in machine learning and such, we usually do 80 to 20 or 90 to 10. You can do that in the project. If it says 50-50, then separate 50 to training, 50 to test. Okay, that's also possible. Just explain, for example, if I were you, I used 50 training and 50 test. Then I increased this training to 80, and here is the difference between 50 training data samples prediction line, and this is 80 sample prediction line. And if I work on the test, the errors will be dropping down, kind of interpretations you can do. Okay. Arkadaşlar, projeyle ilişkiyi kurabildik mi acaba bu anlattıklarımla? Okay, I hope you got the main idea. Okay, let's work on this. Let's work on this problem together. I have a hormone level, okay, milligrams for 24 hours, mother's estriol level, which is something related to the birth weight of the baby, okay? Some hormone level in the mother's blood versus the birth weight. The clinicians are trying to find out a relationship between estriol levels and birth weight. One data is the mother's estriol level is 1 milligram. The birth weight is 1 kilogram. Ahmet is asking, hocam, accuracy hakkında yorum yapmak için error üzerinden mi yorum yapmalıyız? Test train grubu için errorlar yakın mı olmalı? Rakamsal örnek verebilir misiniz? Accuracy is, for example, arkadaşlar, for example, I have 1 here and 1 birth weight. Okay, let's say I'm using this one, and this one for my prediction equation calculations, and I'm going to use these ones for my tests. Okay, for in the test, I'm going to say for 2 I'm finding 1.5, for 4 I'm finding 2.5. Okay, so usually like for the errors, we say the absolute error is 0.5, the absolute error is 0.5, and then you're going to add your errors, and the total will be like sum squared error will be 0.5, right? 0.25 plus 0.25, my sum squared error will be 0.5. So you can represent your accuracy levels using sum squared errors. Okay, sum squared error will be something about accuracy. If this is close to 0, then it's a good accuracy, it's a good performance. If it is away from 0, then it's going to be it's going to be like a high error level. But it all depends on your, if you're talking about 1, 2, 3 or 1,000, 2,000 kind of things, then it all depends. But sum squared error can be used for accuracy performance evaluations. Okay, sum squared error or root mean squared error. There are different accuracy things. Okay, sum squared error, root mean squared error is another accuracy or error analysis tool. Relative error is another accuracy criteria. So you can use sum squared error and root mean squared error for your accuracy things. Okay, for the training, we also do this in machine learning. You have this data, okay, you have this data and you have a prediction. You can find out the error for training, and you can say my error, sum squared error for the training is this. And then now you have this line and you're going to say I have 2 here, 2 is here. You're going to predict it, but the actual value is here. So there is this error. For predicted values here, actual values here. So this is going to be your error. So you're going to say my training error or training accuracy is this. My test accuracy is this based on sum squared error or root mean squared error. Is this clear arkadaşlar? Ahmet, did I answer your question? Okay,
Yes,
hopefully
hocam.
yes. Now I want you to come with me, okay? This is estriol level and birth weight. We all start with what? Scatter plot. Okay arkadaşlar, scatter plot. So this is 1 versus 1. This is 2 versus 1. You know, this is the data. 1, 1, 2, 1, 3, 2, 4, 2, 5, 4. Okay? So 1, 1, 2, 1, 3, 2, 4, 2, and 5, 4. Okay? You can see that from the figure. This is estriol level and this is birth weight. This is X and this is Y. What do I want to find out? I want to find out what would be the effect. Can I predict the birth weight of a baby using the estriol level of the mother before the birth or during the birth? Okay, or during the delivery. Delivery means doğum. Okay, delivery. Doğum. Okay, give birth. Doğum yapmak. Okay, so what's the main idea? I am trying to predict the birth weight of a baby using mother's estriol level. Using the data that I have, I'm going to come up with a prediction equation and find out the errors, how good I am doing this. Okay, how do I find this prediction line? What was my prediction line arkadaşlar? Y hat is equal to beta 0 plus beta 1 hat X. What is beta 0 hat? It's going to be Y bar minus beta 1 hat X bar. What is beta 1 hat? It is covariance of X and Y and variance of X. Okay. So how do I find beta 1 and beta 0 will be my point. It will be the whole stuff. Okay. So here is my X values 1, 2, 3, 4, 5. My Y values. This is estriol level, and this is birth weight. Okay, and then this is the total value 15. This is 10, and then how would I come up with the mean? 15 over 5. The mean is going to be 3. The mean is going to be 10 divided by 5 will be 2. Y bar is going to be 2. How do I find the the difference between xi and 3, it's gonna be -2, okay? 1 minus 3, 2 minus 3 minus 1, 3 minus 3 0, 4 minus 3 1, 5 minus 3 2, 1 minus 2 minus 1, okay? Minus 1, 0, 0, and 2. So these are gonna be my xi. Birisi yanlışlıkla mikrofonunu mu açtı arkadaşlar? Peki. So using this, you can find out xi minus x bar. Then we're going to take the square for variance. Or we were going to use the same thing as for my covariance. So this is yi minus y bar. Okay, these values. And then we're going to find out the covariance and variance values. Okay. So we find the covariance xy being 1.75 and variance being 2.50. Beta 0 is, this is 3, this is 2. Beta 1 is 0.70, this is 0.70. And times 3, this is x bar, this is y bar, and this is beta 1 hat. And then I'm going to find out the intercept being minus 10. So if you think about this line, what is my prediction line? 0.7x minus 0.1. This is my prediction line. You see, this will go to minus values. The slope is going to be 0.7. And now I can say if the mother's estriol level is 2.5, can I find the corresponding birth weight of the baby? Yes, using this equation, I can do that, right? I'm going to put 2.5 here, 2.5 times 0.7, which is something like 1.75 or something, minus 0.1, it's going to be, this is 1.5 or something like that. Okay? Do you understand, arkadaşlar? If I have the prediction line, now I can predict all estriol levels to find out the birth weight of the baby. Even though I don't have any information from these 2.5 milligrams, 3.5 milligrams, or 4.5 milligrams in mother's blood estriol level, we don't know the birth weight, but I can predict the birth weights using estriol levels. Okay?
Hocam,
yes.
Should we not be adding the error? Should we not be calculating the error and adding to our equation? So that any prediction that anyone wants to make, they should consider the error from our prediction line.
So for the training, you put the error like as I said, like sum squared error. You find the sum squared error here for all your predictions. For example, this is your data. You find it here. For example, 1, 0.1, 0.6. Actually, it's 1 kilograms, but we found it as 0.6. So there is an error here. There's an error here, here, here. But this equation is the one that gives us the minimum squared error. We know that. So that's how we should do it. But totally, we should give the sum squared errors and then R squared values, and we can say that the predictions have kind of an error. Okay, all the time the predictions or estimations might have an error. We should be aware of the situation like that. Okay. Özlem asks a question. Grafikteki çizgiyi çizmek için hesaplamalar sonucu bulduğumuz prediction equation eğimini dikkate alıyoruz. Exactly. Yes. For this prediction equation, we use this beta 1 hat here and beta 0 hat here. Okay. For example, how would you draw how would you draw if I give you y equals, let's say 0.7x minus 0.1? You start x is equal to 0, y is equal to minus 0.1. So I'm going to put one thing here. If at what x y is going to be 0, I'm going to say 0.1 divided by 0.7 is going to be my x, 1 over 7, which is like 0.15 or something. This is minus 0.1. This is 0.15. And my equation will be something like this. If I give you this equation, you can easily draw this, right? How do I find this 0.7 and 0.1 minus 0.1? From the equations, covariance and variances. Okay, we do the covariance and variance calculations and do the draw this line accordingly. Özlem, is this clear?
Yes, hocam.
Okay.
Thank you.
Okay, guys. Now I will give you another. So what does this mean? If the estriol level increases 1 unit from 1 to 2, what did we find? 0.7 kilograms of birth weight will increase. So if 1 is 1, if there is 1 kilogram increase, 1 milligram increase in the estriol level, this will be 1.7. 1.7, like, because I know that this is if I increase 1, and if this is 1 kilogram and this is 1 milligram, this is 2. If I increase it from 1 milligram to 2 milligrams, how will my birth weight change? It will change 0.7 kilograms from 1 kilogram to 1.7 kilograms. Okay, so this is how we interpret the slope like that. Okay, I ask a similar question to this one. Last final exams, one of the last final exams, and this is something for you. Now I want you to do everything by hand using some tables. Okay, now I want you to use this values first. Here is how I ask questions in the final exam. Plot the scatter plot first. Okay. Then find beta 0 hat and beta 1 hat, and then come up with the prediction line. Okay, or prediction equation, and then find some squared errors for this prediction. And the final question is like, if food of the cows, I feed the cows 4 kilogram, each cow 4 kilogram, and I obtain 3 kilograms or liters of milk, 6 kilogram food, 5.5 kilogram or liter of milk, and so on. Okay, this is like food versus milk yield. Yield means yani yemek veriyorsun, ne kadar süt alıyorsun, süt alımı gibi, süt neticesi. If I feed the cows 8 kilograms of food, what would be the milk yield? Okay, so you don't know this 8 kilograms, it's not here, it is somewhere here. What would be the milk yields? Okay, now it is for you. I want you to do this on your own. I can do it as a quiz. Let's see how it goes. Okay, please start the scatter plot. I don't want the scatter plots from you, but I want beta 1 and beta 0 and some squared error. So I want B, C, and D from you. Okay, and
Hocam, are we doing it right now?
Yes, you're gonna do it right now, arkadaşlar. These are two. Food is independent, arkadaşlar. Food is independent variable x. This is x, and this is y. Okay, this is x, this is y. I want you to write to chat. For example, beta 0 is this, beta 1 is this. But I want you to use your pen and pencils and papers, okay? to do these calculations. Let me write the covariance again.